Welcome to the FAST training. So this is the demonstration and lecture parts of the one-day training course for FAST. Here's an outline of it. It's going to be a fairly long video. There'll be chapters in it, so you can skip forward and backward. I'll also put timestamps for the chapters in the description. The first thing we start with on the one-day training is a general overview of FAST. People are encouraged to watch the two videos that should also be on this website, the short introduction to FAST and then the long introduction. Those are about the theory and the science behind the model. Today's going to be mostly about using the model. So I'll usually go through those and ask for any questions, but if you haven't watched those, you should probably stop this video and go and watch those first so you understand what the model is actually doing. Then we're going to just go over the graphical user interface, a brief overview of what that is. We're going to run some examples. We're then going to go over the fish parameters, what those are, how you get them. We'll go over the habitat and interaction terms and parameters, go over the predator parameters, hydrology overview, and then I'll just introduce a final project and show you how I might tackle that. Okay, so hopefully you have FAST installed, as I do right here. So just to remind people, there's instructions inside FAST when you've downloaded it off our site, our GitHub page. It'll tell you how to install it. But just a reminder, you want to get a command prompt. Oops. You want to get a command prompt shortcut. By starting Windows and typing CMD, you can then go to Open File Location. You can then copy that command prompt, put it on your desktop. Then you're going to go in and make some changes to it, and I'll just show you what mine looks like. You're going to make two changes to it. One, you're going to say where it's going to start. Wherever you installed FAST, so you should have a section where the FAST model is, and there should be a bin file in that. You're going to start this command prompt in there. So you want to copy that path to that bin file. Then up here, there's going to be a target, and that's going to have some code already in it. That's going to look like this, cmd.exe, and then you're going to copy and paste in. There's a command inside the FAST file you downloaded that says the command to run it. You're just going to copy and paste that in here with a space in between it. And then once you click on that, it should run. And then there's the icon if you want to put the icon in there and all that. So I'm just going to open FAST up so you can take a look at it. Okay, so here's the interface. It's based off of a sort of minimal version of QGIS. All the features of QGIS are in fact in here, and it'll remember what you left set up when you close it. So if you want to add more features back in, you can go into the settings, go into the toolbar layout and add them back in. But as by default, it's sort of stripped down, so there's minimal stuff, just mostly the icons for FAST and then some stuff for basic geometric editing. So down here we have our layers panel, which will show the layers once they're in there. I have a browser window up here. And so one thing that's convenient to do is put a favorites location in here where you're going to do most of your FAST work. And you can just basically find them inside the actual file structure of your computer. So if I were to go to my C drive and find my own section, I could then make a favorite to it and rename it to whatever I thought was good and convenient. So it's right there, ready to go. Here we have some things for loading data. Up on the top here, we're going to have our basic menu bars. So things like view, edit, stuff like that. Below that, some saving stuff, some basic stuff for looking at layers. Then below that, we have all the editing things for if we decide to edit any shapefiles. Those will all become active when we do that. As far as FAST specific stuff, there are 5 plugins right here. And there's a 6th one that's not a FAST plugin, but a convenient plugin to use. So those are all loaded right there. We'll go over each one of those very shortly. They're also up here inside the FAST menu on the menu bar. All right, so the first thing we're going to do is open up just an example file. So I have one here in my section of files. You can open this either by, if you have access to it through here, clicking on this, and this will just open it up. Let me confirm that. or you could go to Project, Open, and then navigate to it through your standard file picker menu and pick it that way. So the important thing to remember is that GIS projects are now, or sorry, QGIS projects are actually FAST projects now. So a FAST project is just a QGIS project with a set structure of layers inside groups. And so what I mean by that is that you will basically have all these groups, which are very specific names, and inside each of one, you're going to need to populate them with a layer. And then when you run fast, you'll know where to assign the layers and where to look for them from the model. What this also means is that it's important to remember that each of these data sources, so for example, I have, a daily environmental data here. If I open this up, sorry, top in there. If I open this up, this data is not contained inside this QGIS program. Its program is just simply pointing to a file. So if you're in here, and we're going to be editing some of these files later on, and you edit something, it's important to remember that if you have another fast run that's also pointing to that file, and you were to sort of open it back up after editing it in a separate fast run, you would have also changed that other fast run because it's just simply pointing to the file. So it's important to remember, what files you're changing, when you're changing them, or you're changing multiple fast runs at a certain time, because it's simply just pointing to where some files are. It's not saving the file or the data inside this program itself. Okay, so we're going to close that. So the first thing we'll do is we'll just run this program. I'll just show you kind of how it works and what it's going to look like when you do. So the way you run a fast run is you go over here and there's a little play button with the fast in front of the fast logo. So if I select that, it'll say run fast simulation, select your output. So you're going to have to decide where you want this your output folder to go, which will contain all your output files. So we're going to go to my desktop temporary folder. I'm going to delete that. Okay, so we'll go here. So now I'm in my temporary folder on my desktop. I'm going to select that folder. There's also a checkbox here if you just want to do a short little run and preview some of the outputs and some of the inputs and how they line up and make sure everything's copacetic and your hydrograph looks good. You can do that, but we'll do that later. So I'm going to hit go, and then a command prompt or console is going to pop up. And what it's now doing is it's now loading all the necessary R packages. First time you open this up, it'll take a little bit longer than other times. After you do it once, it kind of goes faster. But it's going to load all the R packages, give you standard R warnings, like certain packages mask other packages, things like that. It should all be fine. And so once it's done with those, it's going to start doing actual fast stuff once that progress bar pops away. And you can see now it's doing actual fast things. So it's loading parameters. It's making the daily environmental file. It's finished that. It's making the daily fish file. It's giving you a warning, which we'll talk about later, that some of the fish are moved because they're outside the model time window. Making the fish file, making the preview map. Now it's making the model grid and making the shade file. So I'm going to pause the video, and then once these are done, we will come back and look over some of the other outputs. Okay, so the model finished running, so I'm going to scroll back up here just to show you what the outputs look like, or the progress report looks like, rather. Keep going here. So yeah, there's our warning about the fish. So then we go through a bunch of other steps, making various files and just finding out they're done. Then it starts a NetLogo run, the agent-based model. Goes down, puts out the timestamps of every day as the day is completed. And then afterwards, the run's basically finished at that point. It just loads a bunch of images into your output folders and then makes the two reports, which is a bunch of markdown language letting you know it's done. And then it says fast run complete. And then there's some warnings about naming convention and stuff that are just there. You can ignore those. So that is what a fast run looks like. And let's go look at the outputs it made. So if we go to temp, it's going to save, when I selected the output folder, I selected the temp folder, it's going to make a folder that has the name of this project, small dis chinook, and then it's going to say _outputs. And so that's going to be small addition outputs made just now. So open that up. It's got a whole bunch of data files and tables. And then it's also got some shape files. And out here, it also has, these are called temporary files. These are files that are just made to be passed into NetLogo, so you can usually ignore those. Yeah, so let's look at some of these a little bit closer. So here are the three sort of stars of the show. These are the reports. So there's an adult report, a general report, and a juvenile rearing report. I'll just open the juvenile rearing one. So the report is, all three reports are kind of structured in the same way. There's going to be a summary table at the top. Then there's going to start being figures with some descriptions of them. If the figures have data that can be put in a table, sometimes that'll be broken out at the bottom. Yeah, and so they'll have all that output data, and then they'll have all the inputs that you put in, so you can see what exactly went into generating this report in case there's any confusion about what data was used. Yeah, so the other two are also like that. I'm not going to show them to you now. So I'm going to show you a few other things. The main ABM files that come out, those are all CSV files. So we have the ABM cell info, which is information based on the cells. An events one, which is I think a daily summary, so information based on events, and then a detailed population output, which is information based on each fish. So that's sort of where all the data summarizing the ABMs come out. And they're just large CSVs with headers that are described in the documentation. Shapefile I'll show you. In here you can get the river grid, as well as some information put on the river grid about specific fish that are in there, like Chinook adult, Chinook migration path, things like that. I'll just pop that grid into FHAST so you can see what it looks like here. So this was our center line. So what the algorithm did is it smoothed this out and then looked at the inputs we put for the resolution, how far out we wanted the sides of it to go, and then it made a grid like that. So let's look at our grid here. Let's grab river grid shape. So pull that in there. Let's move that to the top. So that's what the grid looks like. Yeah. So I'm going to delete that out of here. We don't need that. In there. Okay. So the next thing I want to go over So now if you're following along at home and trying to do this at home, now would be a good time to see if you can actually run one of these example files just on your own computer and make sure you don't get any errors or things like that. So if you're able to do that, we can go on to the next thing, which is we're going to look at each of these plugins first. So these are the 5 plugins I mentioned before, and we're going to talk about what each of them do. So I'm going to close this project. Changes. So the first one I want to go over is this one, which is called the FHAST Template Maker. Now you remember I said that effectively the way this works is there's all these groups, and FHAST finds the input file inside each group based on the name. So what this does is it just simply makes those group names for you. It's important the group names match exactly what FHAST is looking for, so we have this automated so you can do it. So this just simply pops in empty groups in there, and you can start putting files in there. So let's talk about putting files in places. This is a QGIS interface, so you can load them the way you'd load layers. There's one way to do it. So if you're loading shape layers and stuff, you can do that. You can also drag and drop them. So I'm going to go to my example data here. Oh, not there. So for example, if I had a cover layer, I could load this through there, or I could just simply grab, drag and drop the cover file in there. I then want to move it below where it's supposed to be over here. So this is the cover file. It should be inside the cover category. So I want it to be in there for the run. If I want to be slightly more efficient, I can always highlight cover and then go and drag it in. And I'll just pop it right where it's supposed to be. So you can do it two ways, with the one exception of you should not load the CSV files the way you might typically load a CSV file in QGIS, which is to say you should not do it this way. Add delimited text layer. Not sure why, but the reason they have this set up in a certain way where if you load it through a delimited text layer, they're not directly editable in QGIS. We want them to be editable because you might want to change stuff. So for text files, you're either going to want to load them using one of our plugins, or if you want to load them manually, you're just going to want to drag and drop them in there. So if we get daily, I guess, let's do the this one. So I'll just drag that in there. There's the scale. Final input. Yeah, so then if I were to open this up, I can see it. And also because I dragged and dropped it in there, it's not editable currently because it's locked, but I can unlock it with the little pencil sign there and then make that editable. If I want to. That. Okay, so that's the first plugin. So let's close this project. So the next plugin I want to go over is a fast template maker and file maker. So under each of those specifically named groups, you're going to have a file. And those files frequently will have formats that FAST is looking for, input structures, so it can find how many fish you want and things like that. So what this does is this will make dummy files under each of those that don't have any useful information in them but have the correct structure. So if I click on that, we're going to have a few more options than we did with the template maker. The first thing is that there are going to be some shape files in here. And as such, we need a projection. And so there's one default projection loaded here, which is the one we just did most of our work in developing FAST. But all the projections are available through here. So if I wanted my other California projection or whatever, something, I can go in there and then here's all the California projections. I'll pick whatever one I want. I'm just going to pick the default one and then select an output folder where you want all these dummy files to go. I guess here, maybe I'll put them in a new folder. Dummy. Okay. Select that folder, hit OK. And then we're going to see it populate and make all the groups just like it did last time. But under each of those groups, there's going to be one, or in one case, multiple files. And so, for example, if we look at the dummy cover shape file into the cover thing, I'm going to zoom to features, zoom the layer. We can't because there's actually no features in it. But if we open the attribute table, it's got the correct headers in it. So an empty shape file, but with the correct format. Same thing is true for any of these inputs. Let's do the fish parameter table. Open that up. It's got all the parameter keywords, but no information. So it's all, minus 999. Clearly not actual data. And then we have all three different types of habitat file you can put in there. Not habitat file, environmental input file you can put in there. And all those files would then be in whatever folder you chose to put them in. So here they are. And then there's one file that's not going to actually appear in here, which is going to be made in here, which is your dummy hydrograph file. The file you put in here to use an actual hydrograph as opposed to make a synthetic one is just a file that points to where it goes and asks you how much of that data you want to use based on start date and end date. The actual hydrograph is separate, so you won't see it loaded here, but this did make you a dummy hydrograph, which is right here. So you can see it's got the correct format of dates, flow, temperature, turbidity, but with dummy data. Okay. So that was the make fast folder and template. So let's close that project. And let's go to, it's called fast file loader. So this is one, if you have a bunch of files already made, you just want to assemble them together into a project. So let's click on that. And you'll see here, there's a selection file picker for every single file you need to make a run, including the optional ones. So you can do this piecewise. You don't have to fill out every one of these. It'll work with just some. So I'm just going to grab a few to show you how it works. I don't want to be there. Let's go to my sample data and let's go to the grid. So this is the grid top point. So let's do the top point shapefile, right? Grid top point, yeah. And let's do the cover file. That one. Let's put in a text file. How about fish population? Okay, so just put in 3 files there. Then I hit OK, and it's going to make all the headers again, but it's just going to populate those 3 files I did. And if I want to add more, I can go back, and then I'm going to put in a depth and velocity example raster. There's here, that guy. You can just add them in all the time. And this will load the tables in the correct methodology so that you can edit them. Okay. So one last thing, and I guess I'll do this. So I'll open this guy. I'm going to open up that basic project again, describe that. Okay, so here's a basic project. So we did the run one initially. I'll talk about this later. This is not a fast specific one. It's a useful plugin from QGIS. Did that one, did that one. So the next one we want to go over is this add and remove column. So this is mostly going to be with the wildcard file, which we'll talk about more in a little bit, but you might want to add a new fish parameter in this here, in this interface. You could use that for this as well. So this needs to be in here because for these CSV files that we load either through our own plugin or by dragging and dropping, QGIS it's a little bit finicky about adding and removing columns. So I'm trying to get in there. So if I open the wildcard, normally the way you do this is if you make it editable, you can add a column or a new field, and then you can delete fields. The deleting sometimes works. The adding almost never works. So we just made a plugin to deal with that. So for now, this has the type field, the wood field, and the rock field. So let's say I'm going to leave the wood. I want to get rid of the rock field and add in a vegetation field. So I'm going to go to this plus or minus column. I'm actually messing with this earlier. So first you need to choose which file you want to reference. So we want the wildcard one. And we want to, what do we want to do? Remove rock? Is that what I said? Yeah, remove rock, add veg. So remove rock. And then I'll add veg to it. Now hit OK. Open this back up again. Yeah, veg is there now. And you can remove one and add one, or you don't have to do them together. So that is how you would add or remove a column to any of the CSV input files. So those are the 5 plugins that are what sort of make up the core of the FHAST interface inside here. So yeah, so the next thing I want to go over is we're just going to edit some of these files a little bit and then hit run just to show you how that might work. We have our small distribution Chinook set up here. I'm actually going to, how did I leave this one? After the veg there, I'm going to actually edit this and put in, I don't know, the veg for that. Okay. So let's look at how we might edit some of these things. So for example, you could also start to build a fast run by grabbing an example run and then saving all the appropriate files and locations, and then deciding you want to do a hydrograph instead of a made-up flow distribution. So on this one, for example, we have a thing called the daily table under the environmental input file. So this is our daily stuff. So if we open that, we can see here that this is actually describing a distribution that we sample from to get the flow and temperature and turbidity. But we have an actual hydrograph we could also use. So we're going to get rid of this guy and add in a new hydrograph. So we can go and we can remove this layer. And then I'm going to go to my thing to add in and go to the environmental input file and go to daily. Environmental input hydrograph, CSV. So I'm going to click on that. Open that up. I'm going to double check to make sure it's what I want. There it is. Yep. It's actually pointing to one that I think is going to cause an error intentionally. So I'm going to edit that so it doesn't. Purposes. Okay. There we go. And then I'll hit run. Again, we want to select an output folder. Oh, and actually, now is a good time to show you that there's also a notes section where you can add notes. So if you go to, slower, if you go to the properties of the QGIS project, there's an abstract section. You can type in as much notes in here as you want, and those will all appear in the report afterwards. So this is the basic small Chinook run with a distribution. Okay, so yeah, just some basic notes about what it is. And yeah, should be able to hit run now. Oh, and again, it's going to save it to the output, which is fine. You might, want to resave this and change the name, but for me, I'm fine with that. The output's going to be temporary folder there. Select that, and then hit OK. And so then, yeah, so that's how you would change a file. And then I'll show a quick example of editing something. So this is going to chug along. I'm just going to close this by hitting, you hit Control C, and that should terminate the run, I believe, or you can just close it. So the next thing we could do is we could change not a file, but edit a file. So let's open the fish population table. Looks like we got 10,000 fish in here. So I'm going to edit this to 20,000 fish. And so you can edit things like that, or you can, make them bigger if you wanted to, 6 centimeters on average. Save that. So it's good. Everything's good. Then just hit run again. Same thing. Go. And then it'll run, but now you've changed your files. Okay. So for an exercise now, if you're still following along yourself, what I would recommend is looking at the doing a couple things, opening up any one of these examples and maybe just changing one or two things in there and seeing if you can run it. And then once you're done with that, maybe try to open up this guy and see if you can just go in and, as an exercise, just pick an appropriate file for each category out of the example data sets. And so you can get a run together out of those. Okay. So moving on. I'm going to show one more thing, and then we're going to get into the fish parameters overview. At the heart of this is a NetLogo run, and the pre and post processing is done by R. So it's actually 2 programs in the background, and the GUI is actually run in Python. So there's actually 3 different languages working here. Those of you familiar with NetLogo might know it for its sort of pretty friendly graphical user interface, where you can actually see your little agents run around. Unfortunately, the R program that we're using to call NetLogo always runs in what's called headless mode, meaning they do not let the graphical user interface pop up. If you want to be kind of an advanced user, you can actually see one of them, but you'd have to do it in this sort of roundabout way, which is you have to go to wherever you've installed FHAST and find the actual FHAST code. So I have it here, but it's actually pretty deep and far inside the structure. So you'd have to go to the Run FHAST Simulation folder, which you can just search for, and then you'll find FHAST in there, and this is where your scripts are. So this is the actual R project. So if you open scripts, there's a NetLogo script, and right in there, there's an NLogo file, which is a NetLogo program. So if I open that, we should get our standard NetLogo window. And because I just edited these runs, hopefully this actually does work. I just terminated those runs midway through. We'll see if it works. If it doesn't, we'll just run again and do it. But yeah, so here it is. And if you do setup, it crashes. And that is because it needs to point to the temporary folder that I mentioned earlier while the NetLogo inputs are. So let's go to our desktop here. And let's go to this small, I guess I'm going to try this one, it doesn't work, small distribution of Chinook. And let's go to the temporary folder and let's just copy that file path. Go over here to the folder, delete the 0 that's in there, set that in there, setup, changed. So that's good. And then step, yep, so there we go. So there's our fishes running around. Pause that for a second. If you aren't here, you can change the background to be, the shade. What's shaded or what's the depth, various things like that. So if you do actually want to see a video and are sort of want to do some advanced user stuff, you can actually open the NetLogo code itself, put in your output, and then you can watch the fish zip around the river as they do. All right. Okay, so now we're going to get into the next section, which is I want to get more deep into the parameters that you put into these various input files, so you can understand them. Now, there's a model documentation which goes into great depth and has all the data and things like that. So this is going to be a sort of faster version of that. But if we open this fish parameter table, you can see we got 3 fish here. You can add, your own species if you want. But we have quite a number. How many do we have? 48 parameters that go in there. And so I'm just going to go through these actually in the order that they are here currently. They don't have to be in any particular order. And so talk about just generally what they are and what the structure of each of them looks like, just so you can kind of get a sense of what they are. So you have a little presentation for that. So, leave this out here. But the first ones are going to be Cmax parameters. And so Cmax is the amount of food any fish can eat in a given day. And it's defined by 2 things. It's defined by an equation that has this form, am to the b plus 1, where b is usually a negative number. And this is just because of the way it's frequently reported in the literature. It's set up that way. But that is an equation that ends up looking like this, with the sort of curve goes up and begins to sort of shallow up as it goes on. So that's the first part. And the second part is a temperature function. And in FAST, we use what are called beta sigmoid functions for things that are peaked but asymmetrical. So this is commonly used in growth stuff in physiology. We're using it for a couple things actually in FAST. And they have this structure which looks confusing, but is actually pretty easy to translate the parameters into something. There's only 2 parameters. Here we have C and D. And so C basically means where's the peak of the curve. And then D basically says where's the maximum slope of the curve. And this structure also means that the curve then intersects 0 at 2C minus D. So the Cmax equation, the parameters that you're going to see in the input are A, B, C, D, and that's how they go into it. What's this? Fork length versus territory size. It just gets larger as they go up. There's just an A and a B, so it's pretty straightforward equation there. The equations and where they are in the manual are also referenced in all these slides if you want to see them. Turbidity function is pretty complicated. There is this thing where this is your ability to detect prey given turbidity increases in the water. So your reaction distance to detect prey is a function of your length. So A plus B times your length times some turbidity function. Now the turbidity function is 1 below a certain cutoff, which is another parameter you have to put in, and then has this decaying form with one more parameter in it. So it ends up looking like this. Effectively, it's 1 just below here, and then it decays as it goes. Turbidity goes higher. So you get less and less able to see your food. Total length and how it depends on UCrit. So this is critical swimming speed. Here's our friend beta sigmoid again. And so this is again a beta sigmoid times a equation that your length specific, so critical swimming speed decreases as you get larger. So you can swim fewer body lengths per second as you grow. Yeah, just an example of the sturgeon data there. Max move radius. So this is one of the hardest and most poorly parameterized aspects of this model, and a fair number of models actually, is just how far can fish have information about their environment to make an educated decision about where to go in a given day, right? So it's kind of like how far do fish explore to find new habitat within a given day. It depends on length. We have sort of 2 studies that sort of, by watching fish movement, can give you a reasonable guess at that. And so we just effectively use those 2. It's just a power form of the function. This is not any particular function. This is meant to show you a logistic function, and there's a lot of them in FHAST. And the way they are defined, so a logistic function would obviously have this exponential mathematical form that has a slope and an intercept that's exponentiated, but that's a little bit vague and hard to visualize. So we're stealing something from InStreamer and Salmo, where they recast them as having 2 parameters that define them. And these 2 parameters can be translated from the slope and the intercept. So they, again, uniquely define the sigmoid function. But it's just effectively where's the function at 10% of its maximum and where's it at 90% of its maximum. So it gives you sort of a physical relationship to these, what can be rather abstract curves. Here's an example of daily survival probability for Chinook. And it's showing you that at 24 degrees, they have about 90% survival. And then if you go about 2 degrees hotter than that, they're about 10% survival per day, 26 degrees. And there's a lot of those in this. Mass versus length, another power equation similar to exploration distance. This is the equation for metabolic expenditure, so it's all put in log form. If you watched the presentation before, you might remember that this is set up in kind of a way to allow you to change its functional form by setting parameters to 0. So pretty much everyone's going to have an intercept, which is your A parameter here. But then, for example, if you look at temperature, there's two terms in here that only have temperature in them, plus a parameter, but they have 2 different forms. So one is log of temperature, and then one is temperature with no log. So if you exponentiate this one will be temperature, and this one will be an exponential relationship to temperature. And so what you would end up doing is, if you were parameterizing your fish, you would pick which functional form you wanted to use. And so you could either set C or F equal to 0 and have the other one be the equation. And the same thing is true for V. Here we have V, or we have a square root version of V. So those are your parameters. So again, what's that? 1, 2, 3, 4, 5, 6, 7, 8 different parameters there you're going to have to parameterize. Yeah, and so that's just a whirlwind tour of some of the functional forms that are in there. So as you go through and are making those things, you'll have a better idea of what's sort of the out-migration, you know, these logistic equations here, like that logistic equation I showed you. The 1 represents 1% and the 9 represents 90%. All right. Yeah, so for an exercise, you could go into these parameters and change some of them and then do a run and see if you can get a run. Maybe do a run with a parameter and then change one and then look at the outputs and see if they differ in interesting ways. All right. So now we're going to go into the next part of the course, and that is habitat and the interaction terms. And so we're going to jump back into a slideshow to discuss where does all this information come from. So just to give you a little preview here, on this example data we have, I'm going to get rid of my flow raster here, get rid of my center line and my top grid. Okay, so for example, you're going to need information about what is sort of on the ground where your fish are. How much woody debris is there? How much vegetation is there? Is the bottom gravel or cobble or what? And so where are you going to get that information? So let's go back to our presentation here. Okay, so cover sources. So there's a couple ways we get information for cover sources. The first and kind of maybe roughest one, but it has almost universal coverage, is you can go on Google Maps, or if you want multiple images, back to time, you can go on Google Satellite, probably Google Earth Engine too, and look at satellite images and try and digitize features that are visible from the air. So here, for example, is a section of the river, and you see the satellite image on the left and then an outline around it of some important features. And so digitized on the right is sort of a rough representation of, okay, there's sort of open water channel where we're going to put in, you know, some maybe just cobble without much woody debris. Then there'll be a center island, which is going to have a large amount of woody debris. There's going to be this side channel plus island that has wood on it, and then also has woody debris in the channel itself. And then along the bank edges, there's woody debris sort of just from trees and such on the edges. And then if there's flood over bank, there's, you know, vegetation and whatnot. So that's where you can do it, just by digitizing it from satellite. From data sets. So there's lots of land use data sets available. What you're going to have to do, though, is they're all made for a particular reason. You're going to have to see if that land use data set has information that in some way can be translated into usable information for FHAST, which is it needs to have information about wood, vegetation, and substrate. And so if you're working in the section around the Sacramento or Central Valley, we have a map which comes from the Central Valley Flood Protection Planning Area Map from 2016, which I believe gets updated every couple of years. And we have translated this information. It had sufficient information in it for outside of water cover. So translate that information into woody debris and such that you could use for FHAST. And so that's an example of where we found some information and we're able to translate it into useful data. This is the coverage of that one that comes with FHAST. Here's an example of just what we had to do. So there was like percent hardwood, percent conifer, percent tree, percent shrub, percent herbaceous code. We had to then translate those into sort of what amount of vegetation, what amount of wood is going to be there, things like that, to get them to be useful. So you'll just have to read the documentation of the layer to understand, you know, how they recorded things and see if you can figure out ways to translate them to useful values for FHAST. That layer, for example, didn't have any information about below water stuff. So you had to use some gravel sampling information from the Sacramento River to fill in the water section of that shapefile with information about what type of substrate was down there. And use the equation to make a smooth transition of it. And so there's also others. You could obviously go out and just ground truth, a ground survey, a section. Landsat data, you could use Landsat data from satellite if you had, a large enough river and good enough resolution. And then if you want to see, what's below the surface, get some consumer grade side scan sonar, can show you, trees, debris, things like that. So from those, you'll need to collect and make a shapefile that can tell FHAST what sort of cover structures are in the area around you. All right, so next we're going to start doing some editing of some of these things. Okay, so now I'm going to show you, once we have the shapefile, one of the things, probably one of the largest use cases of this, will be sort of editing structures in the shapefiles, like woody debris or cobble or whatnot, if you're going to do some restoration or habitat alteration. So I'm going to open a shapefile. Okay, so we're going to start talking about, or showing rather, how you can manipulate these shapefiles. So the first way is actually not doing anything in the shapefile itself. It's using this wildcard file we were talking about earlier, adding and taking out columns from. So inside your shapefile, let's open this up. If you open your attributes table, you'll see that, and I've organized them here so they look similar, but everything has a class, which is just for the user. FHAST doesn't actually see that, but then it has all these categories, which are veg, wood, and then 4 types of substrate. The only one, I guess I lied there, the only one of these that FHAST actually looks for is it checks to see if there's some called wildcard. And if there are some called wildcard, what it'll do is it'll look at a wildcard file that we have right here, and it'll take whatever you put in there, and you can put in as many things or as few things as you want. It'll replace those values from here in the cover file. So for example, this says wood is 0.1 and veg is 0.2. That means that when we actually run this thing, this veg is going to get changed to 0.2. That'll be 0.2. This wood will be 0.1. That'll be 0.1. And all these will just stay the same. Okay? So if you want to then do some rapid changes in the shapefile, and you can see one more thing, you can see where those guys are. So these are actually, the 2 wildcards are actually the main sort of water features here. So one, I'm going to make it flash, is the main channel there. And this one is the little pond section right there. Yeah, so we can change, for example, the woody debris in that section of, instead of being 5%, it's now going to be 10% when we run. Or you can just open up your wildcard file instead of editing this file and go over here to wood and say, actually, we want a lot of wood. We want, 20%, and then save it, and then run. I'll just discard that. So that's one way to change the shapefile without even changing any aspect of it itself. It's just telling FHAST to sort of sub something out. The next way, which is sort of probably the most classical way to change it, is just to change the attributes table. So you can edit all this stuff. If you have a particular one you want to change, you can just make it editable, put in something, and then save it. I will discard that though. So you can do that with everything. There's a quick edit. So this is this one plugin that is in addition to the FHAST plugins. So for example, if you open that attributes table, it could be hard to know like which one you're editing. Or find one you're looking for. But let's say I wanted to edit, this guy right here. So it says it's got 40%-ish wood in it. It would be hard for me to open the attributes table and like find it. But I can edit it by clicking on it by selecting it. So you use my selection tool. So I'm just got that one guy selected and do this quick edit feature. So it's going to let me change any of the features I want to something new. So it's at 40% wood. Now it's going to be at 20% wood. Okay. And so if I were to go back to that, I see it's 20% wood. So that's another way you can edit stuff. Okay, so those are the ways you can edit the things if you don't want to change any of the actual way the file looks itself. But if you do, and so I'm going to actually discard those changes. And then I'm going to actually export and save a copy of this so I have to mess with it a bunch. I don't want to mess with it too much. So we'll just save this to there. Okay. And if you happen to do this one little thing, you're going to want to actually load this file again, because if you open it if you just leave it opened as it's been exported, it has this weird property where it has a source information that will mess with FHAST trying to find the file. So you're going to want to actually just remove it if you made it. I'm going to remove this one too. And then I'll add it in using the layer, add layer, vector layer, temp, cover new shape, and okay. So then it's in there. Oh, we want to put it in the right spot. So it goes to cover, and then you can look at the properties and the source things going. Yeah. So let's edit this. And I'm going to make it look nice first. Oops. Categorized class spectral. So there's our colorful one. So yeah, how can we edit these shapes if we want to like add new objects into it? So the first thing we're going to do is we're going to reshape something. There's a little thing here, which I think this is supposed to be like, yeah, this is supposed to be some wood that's in there, 100% wood. So I'm going to project this out a little farther. I'm going to add in some more wood. And so let's make it editable. So I'm going to go up here and click on this pencil. I'm actually going to click on this and unhighlight it there. And so if we want to extend it out, we can go to this thing, which is reshape feature. It's got this little sort of droop shape coming off there. Click on that. Starting inside the feature, you can just go out, move around, and then it'll make a larger section of the shape. So I'll save this. Now, this section is going to have all the same attributes as that shape. And one thing that's important to notice is that it has cut away the background of it. So if I delete it, oops, it's editable, delete it, you can see all the way through it. So this part has been cut out. We'll do that. And that's important. It's actually, you can do it. FHAST will not crash or anything if you have multiple layers on top of each other. So for example, if this were water and you wanted to keep all the gravel cobble, but you just want to add in like a 25% square of wood, you could add that in there and not delete the section behind it. And FHAST will just take those two things and assign them both to whatever area they're overlapping in. So that's fine. You just want to be cognizant of which one you're doing because it might change your intent. Okay, so that's one way you can extend a feature out into places. Let's say we want to add a feature. So we're going to add something here. And to do that, we're going to go up to fill ring. So I'm going to add something here, square. So I'm going to click to make a square, and then I'll right click to end it. And it's going to give me the option of what I want to fill in here. So large woody debris, 2% fine, 25% gravel, 0% cobble, 50% wood. Let's say. And then hit OK. And so there's a new shape. The other way you could do this, and I'm not going to show this here, is you could, draw a shape, make it very specific, do a union and an intersection with them. I'm just going to show you some shortcuts though that kind of make it go faster. All right, so the next one we want to do is we want to add a part. So in that case, I had to fill in all the attributes I wanted. But let's say I just wanted to add another one of these, but it wasn't connected, so I couldn't do the thing I just did. So what I'm going to do now is I'm actually going to still have this actively editable. So I'm going to select this guy, and then I'm going to go to add part. I'm going to go here, add in this guy. Oop. Okay, so there it is. And so now I just added in that part, and I didn't get a dialog box like I did here, because this has all the same attributes as this. So I didn't have to fill them in. But if I were to select it, you select both of them, and to delete it, you can see the background still there, which might be fine if you want to do it that way. But maybe you want to delete the background. So you can do that by keeping everything editable, and you can delete a ring. Or sorry, you can add a ring. So I'm going to add a ring. Click on that. And I'm going to want to click right on the vertices of this, which is obviously impossible. So I'm going to engage my snapping. So once I go to it, it'll highlight stuff there and let me just snap to it. Okay. And so I just did that. And I right click when I was done and take off snapping. Go back to selection, click on this, delete it, and you can see it cut the section. Good. All right. Last one I'm going to show you is clipping multiple features all at once. So you can't like cut across multiple features with this one, which we did, which was reshape features. It doesn't work going across boundaries. So what we're going to do is, if say I wanted to work on this section over here, I could clip through these shapes and then cut them in sections and then have little subsections that I can work on. And I'm going to do that by doing the split feature. So I'm going to select this guy, and this guy. And then I'm going to do split feature. And I'm going to click that. Okay, so now I have cut out, and I'll unhighlight this. Now I've cut out that section. So if I did want to start to manipulate these, I can make this whole section one thing, or delete it, or add back in stuff. But that's if you want to clip along across borders. You're going to want to split the features across the borders, and then you can start editing. Okay. So that is how, that is some of the ways, and there's many other ways you can do it. Again, it's a QGIS interface, so if you want to look up different ways of manipulating shapefiles, lots of ways to do it, but those are sort of 3 fast ways you can do it. So for a class exercise here, I would recommend you try some of those out and see if you can get the files to still run. Make sure you don't mess anything up. All right, and then we're going to move on to the next section. The next section is the predators. So I'm going to make this available, discard that. So the predators are going to have one main file that has their attributes in it, but they will have some other things that deal with predators in the habitat file and in the interactions file. Okay, so let's look at those. So the predator parameter table, if we open that, these are the parameters, and we're about to go through them. The other ones that are relevant are, if we open the habitat table, I believe, there is the predators per area. That's the only predator parameter in there, just describes how dense they are. And if we open up the interaction table, I don't believe there are actually any predators in there. There's things that deal with predators, so distance to cover for the fish, how much cover turbidity provides for you, but those are not actually part of the predator, how the habitat relates to turbidity and cover. How turbidity and cover relate to saving you from the predator. Okay. So let's open the predator parameter table. Oops. This guy, and let's go over what some of these are. So, first thing is that whether or not a predator can eat a prey. So predators and FHAST are not agents per se, they don't interact with each other, but they are individuals and they have individual attributes, one of which is length, and the length dictates what their gate limitation is, which dictates whether or not a fish is safe from predation given their size. And so this is based on some equations from morphometric literature, where effectively the prey they can eat is based on this equation of the predator, which looks like that. So as the predator length goes up, their ability to swallow things increasingly gets large. That's the first parameter you'll see. A bunch of the other parameters are how they relate to the environment. So if you remember from the video that talks about the theory behind this, there was one slide which shows how predators, their distribution relates to shade, vegetation, wood, depth, velocity, and if there is rocky substrate or not. And so this is what this equation looks like. It's a logit equation for predicting presence or absence. And it has the attributes of shade, velocity, depth, wood, I guess vegetation, wood, velocity, and substrate. I think those symbols are all correct. And down here is just showing you a graph of what those might look like if you held everything constant and then just changed one of them, given the parameters you have of the model. So here, for example, you can see the proportion in shade increases the presence of smallmouth bass, but decreases the presence of pike minnow. Also have some logistic equations in here. So this is how much the predators are influenced by temperature increasing their activity. And so this is dictated by a logistic equation, which is right here. That's what the R represents. And then there's a base level of predation plus a how much that logistic equation affects it. So another parameter there. So those two parameters are in there. And then the predators, the distributions of their length is dictated by a log normal distribution. And that parameters in there. So those are all the parameters. Yeah, so we have the the length and the standard deviation for the log normal distribution. We have the predator area logistic equation in there. Yeah, so I misspoke earlier when I said it wasn't in there. These are the two, the baseline and the area effect are the They're actually in the interaction file, which would be this parameter and this parameter, and then the two logistic parameters in the predator file for that. Yeah, so that's the predator data. So as an exercise, you might want to try and change some of those and look at the report with a lot of predators in it versus not very many predators in it. And then we'll move on to hydrology overview. So the hydrology, you can have three types. And so you can have a distribution, a linked distribution, or a hydrograph. So this is the most basic one we have right here. And what do we end up with here? Here's our daily table. Let's open that up. Oh, we got the hydrograph in there. So the hydrograph is sort of the most basic one. You point it to a hydrograph that you've made. And I showed one of those before, which had the dates, the temperature, the flow, and the turbidity. And then you say what dates you want to clip from that. And these dates will dictate how long your run is. So your run will start in this date and end on that date. So that's one option. And you want to have the hydrograph just be next to this file in your file structure. So wherever this file that points to the hydrograph is, it just needs to sit in the same location of it. So there's no path issues. But yeah, so that's a good opportunity to look at this preview. So if you hit preview only, when you hit run, it'll initialize fast, and then it'll stop and give you sort of this cryptic error message, but then it'll also say it's not an error because I coded it that way. So there's that. Yeah, so start field with one errors. This is the terminal control language. I cannot make that go away, but this is just, there's another message in here that I did code in, which says preview complete. This is not an error because I'm asking R to interrupt the execution of it. And so if you click OK, these will all go away, but you want to look at them first. So here is just a map showing sort of where the grid is. And it also has this green background, which denotes that the flow rasters are in fact present behind it. So that's good. Here's our input of fish into the model. The fish have a super individual ratio, which is why they have the step function there. And then what we came to see is the hydrograph. So here's the hydrograph. We've got our dates, temperature, turbidity, and flow. Okay, so we close those. Okay, there. So then the other ones you can put in are, we can put in a synthetic hydrograph, which is made by a distribution. So let's remove this. Okay. And then we're going to go to daily. Let's do daily input distribution. Pull that down here. So you can also pull them in through there if you want. Yeah, so what this is lots more detail in the manual, but this is effectively says we're going to make a distribution. We're going to make a fake sort of hydrograph. And how's this flow going to happen? Well, the flow is going to be normally distributed about a mean of 200 with a standard deviation of 100. Every day is going to be autocorrelated with the previous day of 90%. So it's going to draw something for the next day of where to go, but it's going to take 90% of the value from the previous day, 10% of the new draw and average them so the flow doesn't jump around crazy. It's going to change 1 cubic meter per second per day. So it's going to ramp up this normal distribution. So on day number 2, it's going to be 201. On day number 3, it's going to be 202. It's never going to be allowed to go below this min flow of basically 0. And then it goes on to the other one. So temperature has the same thing, and then turbidity has the same thing. So I'm going to make this actually slightly bigger, just for purposes here. And then let's preview this one. So preview only. Yeah. Okay. So if we run that, before we had this sort of hydrograph with lots of interesting features in it. This one's just going to be something that goes up with some noise in it. So you can see here. So you can see here that flow is going up, and I think these didn't even have an escalation value, but this one, slowly increasing flow over these 2 months or whatever. And also there's a date in there, which again is where you start and end the model. Yeah, and the last one's a link one. So I'm going to remove this. And I think I have a link in here. And what the link does is because temperature and turbidity are often correlated with flow. This takes your temperature, takes the flow input, just like in the previous one, has this distribution it can make, but then it has a way in which turbidity and flow are related to it, so that they are correlated in the model. So if we open an attributes table, looks pretty similar to the last one. So there's your flow change is all the same, but then it just says temperature standard deviation, temperature correlation is 1, and then temperature slope and intercept is the equation which dictates how they relate to each other. And then turbidity, same thing, standard deviation, how much are they correlated, what's the relationship between the correlation, so that if we run this, we should get some graphs that look like they are related to each other. Okay, and so there you can see, this one goes up, this one's inversely related, and this one is linearly related. So yeah, so as an exercise, you could run some of those and with different hydrographs and whatnot, and see how they affect things. Yeah, and in the training, we do one other exercise where you're going to go into your hydrograph and make a synthetic pulse. So grab a hydrograph you have and run it through fast, and then make another fast run where you put a pulse in that hydrograph and see what happens. And if it's a big enough pulse, you'll usually see a section of the fish profile where the fish are sort of pushed out, given that pulse, that flow coming through. Okay. Yeah, so obviously, if you don't put in the correct input files, occasionally things will error out. We're increasingly adding more and more error catches in here. So see if I can pull one of these up real fast. I just saw one was in there, right? Looks like we had a bad environmental file we could have. Daily data bad. So let's see what that does. I believe there's insufficient days or something. So I open this attributes table. Let me edit this. Daily data.csv _bad. All caps. Bad. Okay. Save that. Save. So run it and see what happens. Don't want to preview it. Do a full run. I think we'll get an error somewhere, but hopefully it's an informative one. Yeah, so there we go. So we get an error. So startup failed with errors, so not helpful. But we do have a helpful error. So the hydrograph file is missing some or has duplicate days. So we need to go in there and check why we're missing hydrograph days. There's other catches in here about trying to put in a fish input file with no fish in it is one. There's some of them about check what headers you have in your cover file and make sure they're in there. Check what headers you have in your hydrograph file. Oh, a common one is, and I occasionally do this and lose my train of thought, is putting the hydrograph file in here like it's an input file. So I took this daily data file. Let's remove that. and grab this and grab this daily data file and put it in here. So daily data file in here is not what we want to do. Remember, we want to put a hydrograph file, a file in here that points to this hydrograph. This is the actual hydrograph. We don't want that in here. So if we run this, it used to give a fairly cryptic error, but I believe it gives an informative error now. Hopefully. Yeah, so error, too many columns in environmental input file. So that's the error, and then it says down below, you may have entered a hydrograph file, but not a reference file pointing to it. So there's several of those built in for common errors. We're increasingly adding more, so if you ever find one and want to add it in there, you can email us, let us know. All right, and the final thing we do, so that's a sort of whirlwind tour of FHAST. There's more detail inside the instructions manual, lots more detail inside the model documentation manual. Yeah, and so the final thing we do is actually have a little exercise, which you can all try. That's training exercise. So it has to do with the small distribution of wood. Oh, sorry, that's the small distribution of Chinook, or you could use another file if you want to. So we're looking at placing wood cover structures in 4 locations near and around Arden Pond, which is the pond we've been kind of staring at today. The locations are shown in figure 1, so right near the edges, and then this whole section right there. The wood structure will cover approximately 50% of the area indicated. We'll use the supplied hydrograph for an example file, as well as a flow hydrograph, so ×3 the flow of the supplied one in this analysis. So send 30,000 K of juvenile winter run Chinook through the reach, center the pulse of the fish at 9/15/1982 with an interquartile range, which tells you how far they're spread out of 20 days. The fish should start at having like 4 centimeters and a standard deviation of 1 millimeter, and set the super individual ratio to 10. Look at a comparison between the 4 runs. So low and high flow with and without added wood. So I'll just show you some of the stuff. I won't spend the whole time running them. But so for example, to make these things, we could go into our file here, and just like I showed you, you could go into a cover, and we could make it editable, and we could add a fill a ring. And I could make a little shape down here that looks, I'm not going to look back at it, but it's going to look approximately like what they wanted, right? And we're saying this is wood, so did I say what level of wood to make it? Let's say 50%. I'm not going to bother with a look. I can make the rest of these things 0 or whatever, or maybe 6%. I'm going to call this article woody debris, just from my own personal knowledge. Okay, so there's that. And then you could do the same thing up in this area, and they wanted one right there, or whatever. And then the other section is this sort of section, which is water. And so what I would do there is I would clip that section and just reclassify it. So let's go back here. Yes, it's like down there, up around there. Okay. So it's like somewhere in here. So I probably want to cut along here and maybe cut down in that section. So I'm going to select that section, this whole thing, and then we're going to trim, split that feature, I guess, through here, here, and down here, split right there. Yeah, so then I got a feature like that, and I can then assign that to be wood. And you can do that with the, if you want to do it straight to the table, or it's selected right now, so we can easily do this guy, assign the wood to that at 50%. Okay. Save this. So we got this guy right there, and if we click off it, let's do a little investigating of it. 50% wood. Excellent. So you could add in the other ones. Your fish. So your fish population table. You want to open that up. This is going to be your number. This is your date. That's your quartile range. Your length, your standard deviation. You can get rid of the adults if you want to. Your super individual ratio, that's in your interactions section. This is effectively, what do we got, 20? So this effectively says, every agent in the model is actually 20 fish. So it's going to take up 20 times the amount of area, territory in the model, things like that. So you can use that to make your runs a bit more efficient within reason. If you make it too large, eventually they kind of break down. Okay. Yeah, and then so for the hydrograph, you just want to grab the hydrograph, go into your favorite CSV editor, Excel, for example, and just multiply everything by 3 and copy it back in. And then you could do the 4 different runs. Make sure you name them something differently so you can see all the outputs. And yeah, you will have completed your project. And this is a small section, a small number of fish. You're not going to see a lot of differences between them, but you might see a few things, depending on some other settings of the files. Yeah, so I hope this has been informative. Again, lots more data and information inside both the manuals. Feel free to reach out to me, my contact information through my website, conservation.bio, if you have any questions, and enjoy using FHAST.